Hello. I'm going to record me doing the exam so that you can get answers for how I expected you to do the exam. I'm going to do most of this without the special calculator functions, just to show you how I might expect you to do it without the calculator. But of course, if you solve things with the calculator and you get the same answer as me, you get the full point. So no problems with that at all. So I mean, yeah, let's just get started. So therefore 6k is equal to 180, therefore k is 30. I did notice with a lot of your test papers that there was a lack of working out sometimes, which honestly paid off for a lot of you. Most of the time that was fine. But I also noticed that on some occasions you lost marks because you didn't get the final answer right, but because your working out marks were also not really there. I was really struggling to give you process marks or method marks because there just wasn't really anything there for me to grade. So it's definitely something to consider in future. This one, a lot of you made a mistake on this one where you forgot that this -3 exponent applies to both parts of this. And that does significantly change the answer. The end bit, most of you got, which was awesome. But that bit, there was definitely a... So 1 over 3 x squared is my final answer there. It's 10 minus 5x, 2x squared plus 6x. Let's format that a little bit better. Let's move that backwards a bit. Nope, that didn't help, did it? Okay, let's put that over there. Put that there and put that on the left. Okay. Factorizing x minus 4, x plus 2. This one, you split this top bit and split the bottom bit. X minus 6, or sorry, x plus 6, x minus 7. So these two brackets will therefore cancel, and I'm left with x minus 6 over x minus 7. By the way, you don't have to write it on the answer line. That's not needed. I just do it from habit. This one I thought was a really interesting question. There was certainly some different ways of solving this. So the way that I'm going to do this is not the only way of doing this, of course. So now let's do this properly. If I want to find the length AC, I can do the root of 10.7 squared at 10.7 squared, which would give me 0.7 squared, oops, 7, whoops, squared, 15.1, therefore AO is half of that, 7.566, and therefore I can use that to find E. If I draw this as another triangle where I've got A, O and E, and I now have the bottom length 7.566, I have this as 67 degrees. It's clearly a right angle triangle, therefore trigonometry cos 67 is equal to 7.566 over the adjacent AE, therefore AE is going to be equal to this, the 7.566 over cos 67. Where possible, you really, really should be using the exact figures. It's very important that you use the exact figures where you can. I don't know of many places where you're going to lose marks for that, but I suppose there's always a little bit of paranoia in me that wants the exact answers. Or maybe it's just a mathematician thing. Mathematicians like exact answers. Engineers are the ones that do guessing. So 19.36. Okay. This one, I know there's a lot of people that want to know, how do you do this question? Let me show you. I really liked this one. So the first thing, let's break this down into a problem solving step actually, and then we'll go through my solution, just so that you can see my thinking first. Can I move that to the side a bit? There you go. If I can get the area of this sector, and I can get the area of this triangle, and I subtract them from each other, then I have the area of this segment. Nice and easy. So I put all that together. That is 65. Therefore, that is 65, whoops, sorry, 81 minus 65. That bit is 16. Now, that forms a right angle triangle there. Let's give that some middle point, M. You might have given it a different middle point. I saw people calling it H, D, C. Doesn't matter. That doesn't matter. 65. And I want to know, what's that angle? Let's call that theta. So that's the hypotenuse, that's the adjacent. So cos 16 over 65, or sorry, cos inverse I should say. Cos inverse 16 divided by 65 gives me 75.75. So therefore, angle BOA, or maybe I should say that AOB just because it sounds better. AOB is 2 times 75.75, and I get 151.5 as that angle in there. Now that I have that angle, I have got a sector with a radius of 65 and an angle of 151, and I also have a triangle within that with 2 sides of 65 and an angle of 151. So I can do the area of each one. 151 over 360 multiplied by pi 65 squared. Work out the area of this bit. Half AB, 65, sine C, 151. Put those two together and subtract them. Pi times 65 squared minus a half times 65 squared sine 151, but I'm not just going to write 151, I'm going to write the exact answer, 4559, which I feel is accurate enough. Have I been asked for any particular? No, so that's good enough. 559. Okay, next one. Solve by factorizing. This is an AC method question, or a just put it into your calculator's equation function question, but that's boring, so I'm not going to solve it like that. So AC is equal to negative 70. I consider two numbers that will add to 3 but multiply to negative 70. So that's going to be positive 10 and a negative 7. I can now separate the middle part, factorize as much as I can. 2x plus 2. No. There should not be a 2x there. X add 2, minus 7, x add 2. Therefore I get 5x minus 7, x add 2 equals 0. Therefore x is equal to 7 over 5, or x is equal to negative 2. Right, simplify fully. I thought this one was easier if I first factorize the 3 out of the top. It's an unnecessary step. You do not need to do that. But it was easier for me to spot the inside bit. X plus 2, x plus 6. Therefore, this and this will cancel out. And I get left with 3x minus 6 over x add 6. Okay. Finding the area. Now, I considered a few different ways of doing this. I was thinking maybe trapezium, area of trapezium, if I could find that height, and I could find that side and that side. And then I sort of realized, oh, no, hold on. I've got two triangles here, and I can use the area of a triangle formula to more easily find each one. So let's just do that. So I've got two triangles in here, where I've got one on the outside and one on the inside, and yes, of course they're connected. But my plan is to find the area of each one and add them together. Now, that's a right angle triangle, and therefore this is the hypotenuse, and therefore this is the opposite or the adjacent, depending on which angle you're intending on using. So I definitely want that side. I want this side AC. I should probably label this. Let's do this properly. ACD, ABC. So the side AC will be 56 sine 58 or 56 cos 32, depending on your preference. I'm going to go with sine. I don't know why I seem to prefer sine. There's literally no reason to prefer sine. It's just a stylistic thing. 47.5, good enough. So 47.5. I say good enough because I know that if I'm going to use that number, I'm going to copy it from my calculator. So I know that I'm going to be accurate as far as the calculator is concerned. So now I know that that's 47.5. I now need to find one more side on this. Doesn't particularly matter which one. I think I like the idea of finding AB. So I can find AB with the sine rule. AB over sine 43 is equal to 47.5 over sine 102. Therefore, AB is equal to 47.5 sine 43 over sine 102. And just pop that straight in the calculator. So, answer, yes, that's what I want. I want the answer of the previous calculation that I did in here. 43 over sine 102. And I'm going to get 33.1. There we go. Now that I know that that's 33.1, I can do the area of each triangle. So area ABC is going to be half 33.1 times by 47.5 times by sine 35, which I'm going to do on the calculator in the most exact form I can possibly do it. There is probably no need to be this exact. In fact, I would be quite happy to say there is no need to be this exact, and yet I am still paranoid enough from my own school days to still be as accurate as humanly possible at all times. So that's 450. 451. There you go. And now I'll do the same for the other one. Area ACD. So close to ACDC. 47.5. Sine 32. Just double check that calculation that I did. I don't know why I'm suddenly feeling paranoid about that one. 33.1, yeah. Yeah, okay, that's fine. Half times by 56 times by need for exact number, the 47.5 number, sine 32. There you go. So 704, 705. And add the two together. That, add that. $156. There you go. Excellent. Next up, this one was a lovely one. I think I put it in here because I seem to remember last year we really struggled with it. Or at least the people that were in my class last year. So I wanted the nice feeling of reminding you how far you've come. So equals equal to 90. So therefore when I expand this, I get 7x minus 30 is equal to 90. And then I just rearrange that to the other side. Okay. This one. 1 over 64 to the power of a third is therefore the cube root of 1 over 64, which will be the cube root of 1 over the cube root of 64, so 1 out of 4. That would be the root of 2 times 100, which will be 10 root 2. This one, so I'm going to get 2 root 5, add 3 root 5, sorry, totally skipping steps there, wow. I should do that in a bubble at the side. So root 20 is root 4 times 5, therefore 2 root 5. Root 45 is 9 times 5, therefore 3 root 5. So 2 root 5, add 3 root 5, gives me 5 root 5. And now rationalize this denominator. 40 root 15 out of 15, which when I simplify it, I get 8 root 15 over 3. Multiplying out, root 5 plus 1, root 15 minus root 3, I'm going to get root 5 by 15 plus root 15 minus root 3 minus root 3 by 5. So this one I can do in a cleverer way. I could do 5 times 15, work out what that is, and then go backwards afterwards. Equals now root 25 by 3, which is 5 root 3. I think, keep in mind that I'm doing this in my head, so it's a little bit quicker than writing it, but that's 5 by 5 by 3. and therefore 5 root 3. That I think is quicker in my head to do, so I would do that. So 5 root 3, add root 15, minus root 3, minus root 15. Well, those two cancel out. And I get left with 4 root 3. Right, nearly there at the end now. This one, I think this one was maybe a bit difficult because it asked you to keep it in terms of k. So root a, add 1, multiply that by root a minus 1. So now when I expand this, the top bit, I'm going to get 3 root 2 times 8. And I'm going to deliberately do this a little bit slower than I might do otherwise, just because I've got a lot of roots and a lot of fractions. I know myself, and I know that I am very likely to make a mistake with this many negative signs and root signs and fractions. Those three things together in one question, that's not a good mix for my brain. I know that I'm going to make a mistake somewhere if I go too quick. Okay, so this is a good opportunity to use a bubble. I should explain, a bubble is my way of doing extra calculations that won't interrupt the flow of the rest of the working. It just lets me separate things a little bit easier. That's root 16, so that's 4. So that's 3 times 4 up there. It's probably neater to go down to an extra line. So 3 times 4 minus, and that's, so root 8, I know is 2 root 2. So minus 2k root 2 minus 3 root 2, add k out of 7. So that's 12 add k over 7 minus, and I should probably do this in 2 steps just because I was about to do a bunch of things in one that might not have been clear of what I was doing. So I've just rearranged it for now. Minus 2k root 2 minus 3 root 2, and it's all over 7 so far, or will continue to be. There you go. If I factorize that top bit, I can factorize out the negative root 2, and I get a k plus 3 on the inside over 7. And now I can rearrange it again. Minus k add 3 over 7 root 2. Ta-da! And this is now in the form that they want. It doesn't look like a form that we want, but it is. Because I've got 2 bits where now I know that A is 12 plus k over 7 and B is negative, negative, k add 3 also over 7. Job done. Because these expressions are in terms of k, so I have fulfilled what the question asked me to do. It was a difficult one, no denying that. These ones revolve around just knowing what a log is. That's 4, that's minus 1. I'll explain that one a little bit more. That's log base a to the power of minus 1, therefore negative 1. If you consider what a log is, it's asking base a to the power of what is a to the power of 4. Well, then obviously that number's 4. Ta-da. Okay, next up. But then by the same logic, I get 27 to the power of 2 over 3. So 2x minus 1 is equal to 9, 2x is 10, and therefore x is 5. Right, cos 2 theta equals 0.3. Here we go. There's a whole bunch of different ways of doing this. I think my preferred way of doing this is just doing the arc cos, or the inverse cos of 0.3. I get 72.54. And now considering what the cos graph looks like. That was dreadful having. There we go. So 360 is there, and 72.54 is there. There's another one there, which is 360 minus 72.54, so 284.5. Now this one's difficult because you had to find all of the solutions for this range. So most people got one or two solutions, awesome. But I think only one person, well done that person, got all of the solutions. So that's 143.72. And if I take the other one, divide that by 2, oops, didn't press it, 36.3. Now you'll notice that there's a fair gap in between this and 360, which is maybe enough for you to consider maybe there's more answers here. There's two ways of doing this. I would personally do that, add 360 to find out where does it repeat. So 432.5. And same with the other one. Tell you what, I'm going to do this in 2 bits just to make my life a little bit easier. So that's 216.27. And the next one, I take the original 280, add 360, divided by 2. So 647.5. Divided by answer by 2, 323.7. 4 solutions. If you got 2 solutions or 1 solution, I still gave you 2 marks, but I saved the last mark for anyone that did get all of them, because that is quite impressive. And then tan. Consider the tan graph. It's always, so much of this is just, what does the graph look like? There we go. So therefore 2 theta on the arctan. Oh, not 0.3 this time, just 3. That's pleasing. Same number. 71 point, or close to the same number anyway. 71.57. And then add 180, because tan repeats every 180. 251, and I'm just going to keep on doing that, 431 until I'm sure, 32, sorry, 612, and now I'm going to divide each of these by 2. Ooh, there you go, divided by 2. So 35.78. Now, if you're sort of clever about this, because I'm multiplying, if I'm adding 180 and then I'm dividing by 2, it's the same as this bit, add 90. So I'm going to do that bit to save myself some effort. So 125.8. I do love the calculator when it starts giving me these just unbelievably accurate answers. I do really appreciate it. 215.5. 0.8, and one more, 305.8. Okay, that's the whole paper. I realize I did that very, very, very quickly. If you have any questions, please feel free to ask. Yeah. Have a nice day. See you on Monday.